In this video, we're going to be graphically solving a system of linear and quadratic equations. Okay, so we want to graph both of these functions on this graph and then see where they intersect. Okay, so let's take a look at the first one. We have here y is equal to x plus 5. This is linear, so mx plus b. The slope is 1 and the y-intercept is 5. So I cross at 5 and let's see, go like that. And let's see, should cross right there. There we go. That's the line. Okay. And then we also have y is equal to x squared minus 1. That is quadratic. That's the parent function minus 1, right? So we will be, our vertex is going to be down here at -1. Then we've got this here. And then we've got this here. And it's going to look like this. Let's go ahead and plug in one more point or two more points. What happens if I have a 3 or a 4 in that? So if I plug a 3 or 4 in, just so I can get the right graph, 3 squared minus 1 is 8. So I go to 3 and I go up to 8, which is right there. Okay, so our graph is like this. Okay, so it looks like we are crossing at, let's see, right here and right here. Okay, so we know this one was 3, 8. So 3, 8 is a potential solution. And this one, let's see, we started here. Okay, so it looks like right there at maybe 2, comma 3, maybe 2, comma 3. Okay, and it'll be easier to see this on a calculator instead of graphing it by hand. But you can always test your solutions and see if they work. Okay, so we plug in 3 and 8, okay, 3 for x and 8 for y, into the first one. Let's see if it works. So y is equal to x plus 5. That would be 8 is equal to 3 plus 5. That's true. And if we plug 3 and 8 into the other one, we would get 8 is equal to 3 squared minus 1. Okay, so that gives us 8 equals 8, which is also true. So it works for that one. Now let's try the other one, 2, 3. Okay, so I have, oh, one of those should have been negative, right? -2, 3. Okay, so -2, 3, we get 3 is equal to -2 plus 5. That's in this one right here. And that's true. And then let's plug it into the other one. 3 is equal to -2 squared minus 1. That's 4 minus 1. 3 is equal to 4 minus 1 is also true. So those are our two solutions. Okay, let's take a look at the next one. We do have a quadratic and a linear again. So for the quadratic one, it's got a 2 in front of it, but it hasn't been shifted, so we know it's crossing in the middle. If I plugged in a 1, that would give me 2. -1 would also give me 2. If I plugged in a 2, that would be 8. So all the way up here at 8. And if I plugged in a -2, I would get -8. Okay, so I have a graph that looks like this. It's skinnier than a normal parabola because we have a 2 out in front of the x squared. Okay, let's look at the other one. We have a linear. It's crossing at 4. Okay, and it has a -2 slope. That means down 2 over 1, down 2 over 1. It looks like right there we're crossing immediately, and that looks like 1, comma 2. So 1, comma 2 is a potential solution. And then we could also go up 2 over 1, and then up 2 over 1, which is right here is when it would cross, and that is -2, 8. -2, comma 8. Okay, so this line would look like this. Okay, so this point right here is -2, 8, and this point right here is 1, 2. You can plug those in and make sure that you got them. Let's just test one this time. So I'll test the bigger one, the -2, 8. So for the top one, y is equal to 2x squared. I would have 8 is equal to 2 times -2 squared, which is 8 is equal to 2 times 4, which is 8. That's true. Let's plug it into the other one. So it would be 8 is equal to negative 2 times negative 2 plus 4. That is going to be 4 plus 4. That is also true. So those are our two solutions. Okay, a couple more problems here. We've got y is equal to x squared and y is equal to negative x plus 6. So x squared is going to be right here in the middle. Want it here. If I go to 2, it turns into 4. Negative 2 is also 4. 3 would be a 9, which is way up here. And there, okay? And I'll connect those dots in just a second, but let's get the line first. So y is equal to negative x squared plus 6 means I cross at 6, okay? And negative x means a negative 1 slope. So down 1, right 1, down 1, right 1. There's a point where it crosses, right? This is part of my line right here. But this point right here is also part of the parabola. So that's 2 comma 4. Okay, so I can go ahead and draw this part of the line and this part of the parabola. Okay, that's the point 2 comma 4. Let's go this direction, up 1, left 1, up 1, left 1, and up 1, left 1. So this point right here is 3, 9. 3 comma 9, which would be here, and then we get the rest of our parabola right here. Okay. So there we go. We're not going to test those this time. You know how to do it though. Let's look at one last problem, which is going to be a parabola and another parabola. Okay, so we've got the initial parabola is just x squared, just like our last problem. So here we go. Here 2 goes to 4 and 3 goes up here to 9. Okay, and then mirror image on the other side. Okay, so it's going to be that parabola. Let's do a different color this time. I'll do it in green to differentiate these dots, or maybe even red. Red will be better. So let's do the other one. It's negative x squared, and it's been shifted up by 8. Okay, so up by 8, but it's upside down. Okay, so it's going to be going down like this. Okay, so if I plug in a 1 or a negative 1, let's see what happens. So y is equal to negative, and I'll plug in a 1 plus 8. And that gives me negative 1 plus 8 is 7. And a negative 1 would give me the same thing if I plug that in. Negative times negative 1, because the negative 1 would get squared on its way out. So that would also be a 7. So 1 comma 7. Okay. And then the next one would be, let's say, 2 and negative 2. So y is equal to negative 2 squared plus 8. Let's put a negative out front too, because of the negative gets turned into a positive 4 because of this exponent, but then the negative out front makes it negative again. So it ends up being negative 4 plus 8, which is 4. And if we did the 2 in there, it would be the same thing because they both get squared to be positive. So it's going to also end up being 4. So 2 and negative 2 give us 4. Boom and boom. That's the same spots right there at 2, 4 and negative 2, 4. 2, 4 and negative 2, 4. We can go ahead and draw those parabolas now. Here's one. And the other one, facing upward, would look like this. Okay, so this is 2, 4, and this is negative 2, 4.